power and so on. Now here in this case, now this is another problem. Try to understand it carefully. Calculate current in 2 ohm resistors using nodal analysis method for the network shown below. And here, yes, we are interested in the calculation of this current I1. Is it right? So for this particular figure, how many nodes we have? 2 nodes. And out of these 2 nodes, one node will be this, another node will be this. Out of that, this will be the ground node whose potential is assumed to be 0 volt. This is the node A and its potential is taken as it is VA. Is right. Then we have 3 currents. This current is already defined. It is given in the figure itself, which is I1. Is it right? This current I will name it as another current, which is I2. This current I will name it as another current, which is I3. Just we are giving the different names. Now when we will solve this problem, we are able to know that where should be this method is different, or whenever we have the dependent sources, how it will be different from the normal method. Just sometimes we need one extra equation. How will be the application of this KCL to this? I will write the same. Applying KCL at node A. We will apply the KCL of Kirchhoff's current at node A. We will apply the KCL at node A and we will prepare its equation. Just right. How will be the equation? Incoming current is equal to outgoing. This I2 is incoming, I3 and I1 are outgoing. This equation will be I2 is equal to I3 plus I1. ऐसे प्रॉब्लम्स को सॉल्व करते समय जल्दबाजी नहीं करना है. Already this current is given, that is I1. That's why I have taken this as I1. And remaining current we have to mark in the figure. जब तक आप फिगर में मार्क नहीं करेंगे, एग्जामिनर आपको समझ नहीं पाएगा which value we are calculating. Is it right? These indication or this writing of these currents or mentioning of these currents in your figure is a lot important. Is it right? I will start from this I2. Here, if this is the current I2, we will start from this point. Here potential is 0. It is negative to positive plus 3, that is plus 3. Then negative to positive, because this is also source. Negative to positive, that is a plus. How much is the source? 0.5 into I1 minus this potential, which is VA, divided by resistance of this complete branch, which is the 4. Are you getting me? I am calculating the I2. I will repeat once again because it is little difficult. Because majority time what happens when we have such resistance, such source and such source, generally we will forget about this kind of the source because it is a dependent source and it is a voltage source. That's why we have to consider addition or subtraction in case of the voltage source. If it is a current source, then we have to treat the current of this branch is same as this particular source. It is voltage source in this case. Now, if we are starting from this point, 0. We are traveling in this direction, negative to positive plus 3, then negative to positive again plus, its voltage is 0.5 into I1 minus this potential divided by resistance, which is 4, which is equal to I3. I3 is the current in this branch, which is 2, plus current in this branch, which is I1, VA, negative to positive, that is, sorry, positive to negative, which is minus, this VA minus 4 divided by resistance of this branch, which is 2. Is it right? VA minus 4 divided by 2. Now we will simplify this equation and we will name this equation as equation number 1. This it is 3 divided by 4 minus this 0.5 into I1 divided by 4. It is minus, it is VA divided by 4, which is equal to 2 plus. It is VA divided by 2 minus it is 4 divided by 2. I am not using any calculations. Now here what we will do, we will shift these values to the next side and all constants on the left hand side. If we are shifting this value to the next side and if we are taking the VA as a common, in that case it will be 1 by 4 plus it is 1 by 2. Is it right? Then if we are shifting this I1 value to the next side, it will be plus 0.5 divided by 4 into I1. Is it right? Which is equal to this constant is 3 by 4 on the left hand side. This is minus, and otherwise this will be the 2. It is 4 by 2 means 2. This is plus 2 and this is minus 2. That value will cancel. Otherwise, I will shift on the left hand side and I will do everything. This is minus. This value will become minus 2 and this value will become plus 4 by 2. That is 2. Now simplify this equation and find out the final equation. Tell me this value, and this value. Yes, answers from your side. Yeah. Saurabh, unmute yourself.
0.75 VA.
This is 0.75 VA plus
0.125.
0.125 I1, which is equal to
0.75.
0.75, and this is equation number 1. Yes, unmute yourself. Who is that? Yeah. Yes, Avinash.
So 0.75 VA plus 0.125 VA equal to 0.75.
Okay, fine. This value is the correct, whatever told by the Saurabh. Yeah. Anyone has the answer again? Yeah. Ruchira.
Yes, sir. Correct.
Correct. Okay, fine. Then here, in this case, now look at, yes, Rishikesh. Unmute yourself.
सर वो सेपरेट किया ना सर 4 के साथ सब लेफ्ट हैंड साइड में I2 की, तो 3/4 प्लस चाहिए ना सर 0.5 आए
ये
ऊपर का सर,
ये वाला,
हाँ यही था 0.5 I1 डिवाइडेड बाय 4 वो प्लस चाहिए ना.
अच्छा, this should be the plus, absolutely correct. This should be the plus, fine. बाकी ठीक है?
हाँ.
तो ये हो जाएगा माइनस, राइट?
हम्म.
अगर ये हो जाएगा माइनस तो ये भी होगा माइनस, राइट? एब्सोल्युटली फाइन. This is 0.75 VA minus 0.25 I1, which is equal to 0.75. This is the equation number 1. Absolutely fine. Is it right? Because by mistake I have taken this value as a minus, but actually it is 3/4 plus this is 0.5 into I1 divided by 4. This will be the value. बिल्कुल सही. This value should be the minus. Absolutely fine. Now, if I'm coming back to you, this is equation number 1. Now look at how many equations we have. One equation. How many unknowns we have? The 2. This one unknown is VA, another unknown is I1. Now what we have to do? We have to find out a value of unknown which is I1 in terms of potential VA. Now if we are finding the value of I1, already we have done that. How much is the value of I1? This value. VA minus 4 divided by 2. Means it is VA minus 4 divided by 2 is the value. If I will simplify this equation, how will be the next equation? In this particular case, I will shift this 2 on this side. Means it is VA minus 4, which is equal to 2 into I1. But I want this equation maybe in this form, in this particular form. Are you getting me? In this particular form. That's why what I will do, this VA, I will shift this I1 on this side and this value to the next side. This equation will be VA minus 2I1, which is equal to 4. Is it right? This is the equation number 2. Otherwise, आप इसको ऐसा भी simplify कर सकते हो. इसको आप ऐसा भी simplify कर सकते हो. कैसे? This I1 is equal to VA by 2. This is VA by 2. This is minus 4 by 2. इससे भी simplify करेंगे तो वही equation आएगा. Is it right? And the equation will be something like this. Now, if we have the 2 equations and 2 unknowns, this is the equation number 1 and this is the equation number 2. Solve these 2 equations simultaneously and find out the values of the potentials, potential VA and I1. Yes, Saurabh, unmute yourself. Yeah.
0.72 VA.
Sorry.
0.72.
0.72 volt is a VA. Yes. Next.
Minus 1.63.
1.63. 63. Yes. Amperes. Yes. Ruchira, unmute yourself. Yeah.
Yes, sir. Correct.
Correct. In this particular case, now we will check. काय? बरोबर लेक्चर मध्ये मी झालं बोलतो. Now here in this case, if this is the value of its current, which is minus 1.63, is it right? And VA is 0.72 is the value. And here is the answer. Where is the answer? Because we are interested in the calculation of I1. Calculation of I1 is minus 1.63 amperes is the value of the current, which is I1. Is it right? This is the I1. Now in this way, let's look at here. Sometimes this may be the current dependent, sometimes this may be the voltage dependent. That may be the one example I may have considered, and we will discuss about such problem.